And is that what we see here? Really? They're not the same?
No, I'm talking about Amaya's and Serenity's denominators are exactly the same.
Okay, I see what you're saying. Now, let me ask you this. With that being said, do I have similar denominators here?
Yes.
So you could say that when we add fractions of unlike denominators, at some point, the denominators must be the same, correct? Can we agree on that?
Yes.
When we're adding fractions, at some point, denominators must be the same. Okay? Is your hand up, Tyrone? I can't tell.
Yeah.
College hand. Yes, what do you see?
I see that Amaya has the same answer as Dalton's because, like, at first, if she didn't simplify her answer, like her denominator would be the same as Serenity's, but Serenity's, like, they did it in another way. But I agree with 5, 6 because, like, 1 times 2 is 2 and 3 times 2 is 6 plus, like, the 3 6 Dalton's 3 6 and 5 6 and the
You going?
okay in like how Amaya multiplied how she divided her answer and she simplified it.
Okay, and I think you just hit on it, but I want to just narrow that thinking just a little bit. I think you just said it, but I want to pull it out for all of us. Okay? The question is, okay, I know that I have to have the same denominators, first off, right? But what am I doing to these fractions here that have different denominators to get the same denominator here? Okay? What step am I taking? How am I going from 3 and 4 to 12 and 12 or 6 and 6? What am I doing? Okay, I'm finding the least common denominator, right? And I'm doing that. How am I doing that? Okay. Multiplying what? Here's a hint. What am I doing? What am I doing right here? Is this the same number here? Okay. Talk to me about this part right here. Let's come back and get some more help, okay? You're on the right path. Brooklyn, talk to me about this part right here. Okay, so I think I could say, let me take a stab at it. I can multiply the numerator and denominator by the same number, which is a factor of 1, right? I can multiply it by a factor of 1, and that gives me a new denominator. Likewise, I can multiply this fraction by a factor of 1, and that gives me a new denominator. But it got to be the same. So the key is tracking me. If I want to find the numbers that have the same denominator, I have to multiply this fraction by a factor of 1 and multiply this fraction by a factor of 1. Okay? That's how I find those common denominators there. Amaya.
What's the question like? What can I add from that problem?
Yeah, so if we want to take these two problems, right, and compare them to what we did over here.
We would they did everything right, but they put their numerator on top of the 12. They set the multiply of 4 and 3.
So you're saying right here, they have the same denominators, right?
They need to change their numerator.
You need to change the numerators.
And they put multiply by 4, or multiply by 3 over 3. 1/3 will be 4, 4, and 2/4 will be 3 over 2.
So one thing we want to get in the habit of doing is fixing our mistakes, right? We want to get in the habit of fixing our mistakes. So Serenity, you did this one, right? Can I borrow you for a quick second? Let's see if we can fix this to get it correct. You want to call someone to help you? Call someone to help you. Now, he's going to help you, but you're going to have to watch and understand what he's doing, okay? Come on. We want to fix this, right? We're on the right track. Denominators are good. We want to fix these numerators. So, he's going to do what you tell him to do, okay? You're going to tell him how to fix it. He's going to write what you tell him to write, okay? Here's what I want you to look at. Like Amaya said, look at what we did here, and then look at how we can fix it here. So you got 3 times 4 equals 12, right? But what should I do with my numerator? Multiply by 4. So this won't be 112, it would be what now? Right? Now say it so, you gotta say it so you can hear it. So the key is I multiply the numerator and denominator by the same number. It has to be both, a factor of 1. So we're fixing our mistakes now, okay? That's how we learn. So, what do you do there? I'm adding, so what goes here? Plus. Now, Serenity, how would I fix this fraction? Multiply what by 3? Love the language, the numerator and the denominator by 3. Love the vocabulary, plus 1. So, that being said, what's my new answer? You know your denominator is already the same, right? 6/12, perfect.
Serenity, do you understand why you multiply by 3? You multiply both the numerator and denominator by 3? You do? Okay. Could you explain why?
Because you have to find, you can multiply the numerator and denominator by different numbers, like multiply by 2.
Yes, equivalent fractions. Like another reason is just like if you think about pictures, if you have pictures, like if we were going to multiply, like this is what you all had told me before. Here's 2 4s, right? And you said multiply that by 3. Well, if I multiply 2 4s by 3, 2 4s, here's another 2 4s, here's another 2 4s. This is 2 4s times 3. 3 2 4s. Is that what you were going for? We were going for trying to make our pieces 12s. So when we multiply both the numerator and the denominator, what's happening is we're just splitting it into more parts. We're just making more parts until we get 12s. But if we just multiply 1 times 3, one of the either the numerator or denominator by 3, we're not going to get the same, we're not going to be making more parts. That's all about that equivalency, which is what we want.
Yep. Okay? Excellent. Love that explanation. Absolutely right. So now, Serenity, we fixed our fractions. How would I add these 2 fractions now? Exactly. If we're looking at our rules for adding fractions, right, that Dr. Hunter has so graciously written for us, we keep the same denominator. So 12 is on my bottom, that's my denominator, and I add my numerators. Notice how I'm using that language, right? Notice how I'm using the vocabulary. So when I ask you to explain your answer, which you know I do, when I ask you to tell me how you got your answer, that's what I'm looking to hear. I kept my denominators the same, or I found a common denominator, right? And then I added my numerators. Or I multiplied the numerator and denominator by the same number. Very precise language, very important. Now, I got 10 over 12. Now, this is not necessarily part of the lesson for today, but 10 over 12. Am I finished? Can I leave it like that?
No.
I can't do that. I can simplify it. I can reduce it. When I reduce 10 over 12, what do I get? Stefan? And do you know how you get 5, 6? How do you go from here to 5, 6? What do you do? Why 2?
Hold on, divide by 2.